Hello, Victor Sanchez with NS Car Wash Systems. Today we are going to be covering the NS RO systems. We're going to create a series of videos that's going to go over the installation, the startup, the preventative maintenance, and troubleshootings of the RO systems. The NS RO system will include a carbon filter. You'll have the NS RO system. This particular unit has 2 membranes. Yours may have 3, 4, 5, 6, up to 10 membranes at most locations for higher volume. And finally, you will have the anti-scalant, which is the chemical and the anti-scalant injection pump that comes with the RO system. In addition to these items, you should also be receiving a polyethylene holding tank to hold the spot-free water, and an NS rinse pump, which will draw water from that tank to deliver to your rinse arch. We're going to be covering the carbon filter. The purpose of the carbon filter is to remove chlorine from the water. The main offender that fouls membranes is chlorine, so once this charcoal loses its effectiveness, membranes will foul almost immediately. Basically, the media here will help eliminate chlorine for anywhere from 12 to 18 months. And you could actually use a meter, a reading, to measure your chlorine levels to learn when this system is losing its effectiveness. So when you get this filter and you're going to work on the installation, it basically will come with this set of valves here that are basically a bypass, so that you could bypass the carbon filter. You're never really going to do that unless we have some type of issue with it, but that goes installed on the back of the RO system as such. When it's delivered, both of these are closed. So once you install it, you'll notice that your incoming line with a little arrow here that points towards the back flush head of the carbon filter, and then you'll have an arrow out. So basically your incoming line will connect to this side with the arrow in, and the line with the arrow out will connect to the water feed on your RO system. So you've got those systems hooked up already, or basically you don't want to hook up the outlet of this filter until you perform a back flush. Basically what you will do is you will go ahead and open this valve, and it's pointing towards the arrow, it means it's open. When it's pointing in the direction of the arrow, it means it's open. When you're going to do the back flush, open this one, leave this one in the closed position. You'll have the water inline hooked up to it, and you'll have this one back flushing out with the hose out to a drain. And also the back flush, you will also need to hook up the back flush drain line. And you want to make them so you can monitor the water coming out of them, the color of the water coming out of them, so you know when the back flush is complete. The water will come out very dark with charcoal dust and particles. And once you flush it several times, you will notice that the water starts to come out clear. And that's when you could go ahead and make the connection from the carbon filter outlet to the inlet of the RO system. Again, this right here is the back flush outlet, and this will come on when the system automatically back flushes itself. But when we're starting up the system, what we're going to do is we're going to plug in the back flushing head into a GFI, and we're going to set the time of day. So we're going to hold this down, and we get the blinking there, and it's right around 9 o'clock right now. So then we'll go over to the next one and change the minutes, and it's about 9:55 right now, and it is AM. So we hit the start stop button again, the set button, and your time is set on the system. Next thing we're going to do is we're going to hold down this 2 buttons for 4 seconds. And what that's going to do, it's going to put the system into an automatic regenerate back flush. And the back flush is set for 10 minutes. So basically what's going to happen here is you're going to watch the water come out of this line, and as soon as you start seeing the water come out clear, then we could end this back flushing, and it'll count itself down. And then once it's complete, you'll hear the motor cycling itself, and then it'll put itself in the mode where it's filtering water and feeding through. Now, once you've completed that process and you're ready and everything's all clean, what you're going to do is you're going to go ahead and you're going to open this valve, and that's going to allow the water on the outlet to go over to the inlet of the RO system. And that's complete. Real important to make sure that you back flush this filter completely. You eliminate all that carbon dust, because basically what it will do is, if you don't, it will clog the micron filter which is in line to the inlet to the membranes, and you're just going to have to replace that filter almost immediately. For startup purposes, we're going to put in a 1 micron filter on all the RO systems we deliver, and then you will have a secondary 5 micron. So after you fill your holding tank and the system shuts down, we could do a reset and we could replace that 1 micron filter that comes upon delivery with the 5 micron. And if you see, any signs of carbon or anything like that, then you might want to go back here and back flush this carbon filter once again, just to make sure that we've got all that carbon eliminated. Now, the second method too that we can use is just flushing water directly through the filter itself, and we just open up this valve and also let water flow before we connect it to the inlet of the RO system. And we could monitor the clarity of the water on the back flush and on the outlet of the pump to make sure that we have eliminated the majority of the carbon dust that comes out in the back flush process. Your RO system will have this communication cable that needs to be hooked up to the RO system. What this does, it sends a signal to the RO system to prevent it from functioning in the back flush process. As I mentioned before, you have a bypass here, and if this is not connected, it will allow chlorinated water to enter your RO system during the back flush process. When you have this hooked up, it shuts off the RO and you eliminate the contamination of the membranes by the back flush water. That is the main function of this. So when you're hooking up your water supply to the RO system, again, you're going to hook it up on the inlet side that has the arrows feeding into the back flush head. The outlet side, you're going to hook up a hose to that, and you are going to bring it over, and the inlet solenoid here has a fitting down below, and you will put on a threaded connector that we will provide, and that's where your outlet from the carbon filter will feed the RO system. While I'm on this side, I'll go over the discharges of the RO system. This is the concentrate. So if you have RO reject water harvesting, this would go to the RO reject water harvesting holding tank. The opposite side is the permeate line, and this line will go to your RO holding tank, and that's where you'll have the spot-free water to use for your rinses. The final piece of the puzzle is the anti-scalant. So the anti-scalant has an outlet. Comes with a series of hoses and outlets, and basically you're going to hook up the hose to the outlet of the pump, this polyflow fitting, and then you're going to come over here, and the same section where you hooked up the inlet from the carbon filter to, you have chem in. You remove the fitting there, and you install the fitting that comes included with the kit. Keep in mind, this has a little plastic coating around the nipple there that belongs on there. A lot of people will try to remove it thinking it's just there to protect it, but it is actually a functioning part of this particular injection valve, so you want to leave that on there. And you just screw it in. Just on any of these connections that you're making into these fittings and these plastics, basically only wrap about 1 or 2 layers of Teflon tape when you're installing these to prevent the expansion of the fittings and cracking and whatnot. We're going to go over the electrical hookups for the RO system. First connection that you'll find is 110 volt connection for the back flushing head. When we design these, we call out a 110 volt GFI 20 amp connector on the wall to plug in for each system, and you'll plug that in on the RO system for 110 volt. This particular one controls the control panel and offers voltage to control all the solenoids on the system. You also have the 460 volt connection. This one you will hook up to a breaker inside the rinse pump panel, which will feed the three-phase power to the system. While this particular system is three-phase, we also offer a single-phase system that'll have a 220 volt plug, and it will also have bare wires on it that you could affix the plug that you want or hardwire it to a 220 volt single-phase circuit. You're going to have two sets of cables coming off of the RO system for low voltage controls. The first one is the pre-treatment. So this pre-treatment comes automatically with the wires connected. So if you don't connect this to the wires on the carbon filter properly and also on the anti-scalant, this will stay automatically in backflush because these two wires are connected. So if you don't have it hooked up yet and you want to cycle the system, we could go ahead and just disconnect these wires for the time being. When you're performing the startup, just make sure they're not making any contact with each other. So that is for pre-treatment. And again, you'll have a signal from a low-level switch coming over from the anti-scalant as well. You just hook those all parallel together, red to red, black to black. Finally, you have the signal that goes to the holding tank. Inside the tank, there'll be a float there to tell the RO system when the tank is full to shut down and stop producing water. Same thing here. If these two wires are connected, RO is not going to operate. So you want to separate the wires, or you want to connect them directly to the float before you activate the RO system. As I was mentioning before, the final setups that you have is that you'll notice that the anti-scalant has a 110 volt plug on it, and some people want to plug it into the wall. Well, you don't do that. You plug it into a plug from the RO system that is feeding off the panel. And basically what this does is when the RO system is operating, it has this continuously providing anti-scalant to the system. When the system goes into high level and shuts off, it cuts off the power here so that the pump does not run continuously. As I was mentioning before, this is the level sensor inside of the anti-scalant. So what this does is it lets the system know that you're low, and it shuts down the system to prevent you from operating without the anti-scalant and fouling your membranes. So again, this will hook up in parallel to the pre-treat wire that we've shown there with the connections from the back flush filter and the pre-treatment on the back of the filter. NSRO systems are available in single-phase and three-phase power. This particular unit is a 460 volt three-phase unit. We build these systems depending upon the voltage that you have at each job site, so just confirm that when you look at the cable that the voltage is compatible with the site voltage. So when you hook this up, the majority of the time what we would do is that we provide a connection inside of our rinse pump panel. The rinse pump panel has a main disconnect built into it, which will act as the disconnect for the RO system. Inside of that rinse pump panel, there is a breaker feed where you will hook up these wires and hook it up. In the event that this is hooked up to a designated breaker, you would want to put in a disconnect and connect this to a disconnect, have a disconnect on the wall for the RO system. if it's not hooked up to a rinse pump. Now, on the single phase panels, it'll be a single phase 220, and it will come just like this, bare wires. So if you want to use a wall plug, you could go ahead and adapt it to a wall plug, or if you want to go ahead and do a hard wire to a J-box on the wall, you can do that as well. Does not require a disconnect. Again, on the back of the RO, you're going to find two thin wires, one that reads tank, the other one that reads pre-treat. This particular one that reads tank, this is routed to a float that goes inside of the RO storage tank. Basically, that float, it will be a yellow float, and it will signal the RO system that when the water level reaches a full level inside the tank, to shut the RO system off. Now, you'll have a secondary float inside of that RO storage tank as well, which is a low-level float. And the purpose of that float, and that float will hook up to the NS rinse pump panel, and that is to protect the rinse pump in the event that the tank runs dry, to keep it from running dry and burning out the pump. Starting up your RO system. On a previous video, we already went through the whole process of back flushing this carbon filter, also discussed the hookup for the bypass signal. And so all of these are going to be completed, and you're going to have your fresh water hooked up to the inlet over here. So once that is completed, and of course you've got your concentrate plug out and draining to a drain or to your holding tank, and then plumb the permeate line to your RO holding tank. So once you have that completed, what you're going to do is you're going to go to the system, and it's going to be powered off. Right now we don't have any power going to the pump, so you're not going to hear any of that because it would just drown out our narrating. So what you're going to do is you're going to hold the start-stop button down for 2 seconds, and you'll notice that there is a start delay. And the reason for that is because this solenoid opens, and we allow the city water pressure to fill the filter and fill the membranes and get water over to the pump so that the pump doesn't cavitate on startup and go into a low pressure condition. So once you have the RO running, it'll be the permeate high flow alarm because it's not connected. It's showing that it is actually full. And then you'll have the permeate TDS, which will show you the parts per million of the permeate, which is the RO rinse water. This will cycle as this is on, so it will give you RO runtime of how many hours the system has been in operation. And you'll also get an inlet TDS reading on here, which will let you know the total dissolved solids of the water that's being fed to the RO. So these are the functions that you have on here. So you have these arrows, which there's no need to operate those at all. And also the manual switch down here is just a switch that you could hold down to bypass all of the solenoids and all the protection that the RO has to make it run, to force it to run manually. We don't recommend touching any of this. The only thing that you need to do is turn the RO system on and turn it off. Here we're going to go over the RO system control panel. Basically, you have the on-off switch here. You hold it down for just a second, and this will start up the RO system. You'll notice that it has pump delay here. Basically, what's happening here is that this solenoid here opens and allows water to circulate through the filters and through the pump, so that when the pump starts up, it is actually has water in it and it does not cavitate. So you're going to notice that you've got a series of information going on here. And basically it tells you the RO system is running. So the permeate high alarm is basically stating that the total dissolved solids are high, and that's because we're not running any water through right now. So it's just getting a false reading. But this will tell you when your TDS is high, and then it gives you the TDS level, which is at 81 parts per million. So where we are at is we like to have the total dissolved solids on the permeate at 25. If it's greater than 25, then we recommend doing a manual backflush, where when we replace this micron filter, we fill this halfway with muriatic acid, screw it back in without the filter, and we go ahead and turn on the RO water in the pump with all the valves open all the way, so that that muriatic acid scathes the membranes. So the other information that you're going to get on here is the water temperature, which right now it's showing 65 degrees. Ideal is 77 degrees for an RO to perform at optimum. We will have, we're used to colder conditions, so we do run a membrane that is going to perform better when exposed to colder conditions. So RO runtime is the final setting that you have in there, and this tells you how many hours the system has been in operation. We're going to go over the functions of the RO control panel. When you have everything connected and you're getting ready to start up, you go ahead and hold down this button for a second, and it automatically starts the RO system. You'll notice the reading of pump delay, and basically it's a 10-second pump delay. What this does is we open up the feed of water to the RO system, and the city pressure infiltrates the filters and the pump and basically allows the pump to be primed before it is activated. So when we're looking at the screen, we'll notice that on the side we have up and down arrows and also a manual run flush switch. Basically, we do not want to touch any of these. The on-off is all that you need to obtain all the information that you will need to operate the RO. So this whole LCD screen goes in cycles, and right now it just tells us the RO is running. So the permeate high alarm, basically this is telling us that the permeate is at a very high level at 81 right now, and it's telling us that we need to do some type of maintenance or service to repair the RO and make sure that it gets down to within the parameters which we set, which we like to see it below 25 parts per million. Then you have the RO unit runtime, and that tells you how many. On this part of the video, we're going to go over the gauges on the system and also the procedures of valve positions that you will need when starting up the RO. So basically, you've got one gauge here that reads pump pressure, and that pump pressure is controlled by this gate valve here. So when you start the system, just softly put it to the closed position, and then you're going to do 2 turns out. There's 1. There's 2. You're going to come up here to these 2 valves. The permeate does not have an adjustment on it, but the concentrate, recirculation, this valve, you're going to keep closed. This valve is going to stay closed for the duration of the operation of the RO system. We do not like using this particular function of the RO. We prefer to go without. Then on the concentrate flow rate, this one, you will make sure that the valve is closed, and again, you will go and do 2 turns out. And you can measure the turns by a little hole it has here that has a Phillips screw to secure the lever, and you can measure the turns there. So then you'll go ahead and start up the system. We're not going to start up the system right now because it'll make a lot of noise and you won't be able to hear us over the noise. So we're going to explain the functions here. So you've got the pump pressure. So with that valve open, pump pressure is going to be right around 80 psi for initial startup. So you want to see that at about 80 psi. Another way to control it too, pump pressure, if you can't get it off there, you also control the concentrate. But what's going to happen is that you're going to adjust the concentrate to achieve the levels that you want here on this side. So this basically tells you on this side the gallons per minute that you're producing. This tells you the gallons per minute that you're discharging. So this particular system, being a 2-membrane system, is going to produce right around 2 gallons a minute. Anywhere from 2 to 3 gallons per minute is what it's going to produce depending on the actual water temperature. So you're going to make adjustments here to get this somewhere in the 3-gallon neighborhood and to get this right around the 6-gallon neighborhood. So basically a 2-to-1 rejection rate. As you're doing those adjustments, you're going to notice that the pressure on the pump is going to fluctuate. So it's a balancing act. And basically, when you have new membranes, you want to run the RO system, the membrane pressure, or the permeate pressure, the pump pressure, at about 80 psi. The max pressure that you want to run on these membranes at any given time at the end of their life cycle is about 150 psi. No? So once you've made the on adjustments to get the RO started up, you are going to want to adjust the pump pressure, and you're going to want to adjust the concentrate release on the gallons per minute on that. So basically what we're going to do here is we control the pump pressure. It is going to control the amount of permeate water that you're making. In this particular case, with the 2-membrane RO, it should be generating right around 2.5 to 3 gallons per minute. So you're going to want this gauge to be sitting right around there or just right below the 3-gallon per minute line. This one is always going to remain closed, as we said before, so there's going to be no reading on that one. This particular gauge here, since we're want to do a 2-to-1 ratio, this one is going to be right at about 6 gallons of rejection per minute. So you're going to set it there. So as you start making adjustments to these, it's kind of a balancing act. So once you get that set up, you could go ahead and you could twist the valve to reduce pressure or open the valve to increase pressure. So counterclockwise open, clockwise close. And you just want to make sure that you're achieving the pressures that you are looking for, which on this particular one is just below 3 gallons a minute, 3 gallons, and the 6 gallons per minute on the rejects. So you'll be playing with that. And then the pump pressure will fluctuate. Depending upon water temperature, the lower the water temperature, the higher pump pressure that you're going to need to produce the water that the system's designed to produce. So your operating PSI will vary depending upon locations. Warmer weather, lower PSI. Colder weather, higher PSI. You can operate these systems all the way to 180 PSI. Do not exceed the 180. So we've gone over the pump pressure gauge. Now we are going to talk about the concentrated pressure. So basically the concentrated pressure is going to be less than the pump pressure by about 50 psi. So basically this is a 2-membrane system. The more membranes that you have, the bigger the pressure differential will be. So you take note of your pressure when the system is started up and it's running optimum. And as you see the pressure start to decrease on this pressure gauge, that means 2 things. It means that you need to clean the RO, service the RO membranes with muriatic acid flush, or replace the membranes. First, we always try to do the muriatic acid flush and then see how our pressure differential is after that. So the 2 gauges below, this particular measures the filter in pressure. So this measures before this 5 micron filter here, and this one gives us the pressure after the 5 micron filter. So let's say you're getting 40 psi, and this one with a new filter should read 40 psi. As this filter goes through its life, it'll decline and you'll see a drop between in and out pressure. Once that out pressure difference is more than 10 psi, it is time to replace that filter. We generally recommend replacing that filter every 30 to 45 days, a rule of thumb. But you can go longer if you notice that your pressure differentials are in the right parameters. Again, if it's greater than 10 psi, it's time to replace it. another good rule of thumb is doing it every 30 to 45 days, is so that you can go ahead and get the anti-scalant system back up to speed, fill it up. When you have your power connected, you're going to have to check the rotation of the pump. And basically down here, you'll notice that it shows you an arrow for the rotation. And this one is the rotation going in this direction. So when you start up the RO system, you'll start it up and then you'll look at the top of this screw here, this mount, and you see what direction it's turning. If it's turning, it needs to be turning in this direction. If for some reason it's turning the opposite direction, you need to open up the panel and basically take these two wires and switch them from each terminal, and that will switch the rotation of the motor. This only applies to 3-phase. If you have a single phase, the motor will automatically spin in the correct direction. In the previous video, we went over the settings for the gate valve on the pump and also the concentrate flow. So 2 turns out, and yes, that should help evacuate all the air from the system. But basically, before you make the adjustments, the final adjustments that we discussed, you want to make sure that these valves are flowing pure water and that you don't have air bubbles. So you definitely want to watch that for that. And once you see water's flowing and no more air bubbles, then you can go ahead and proceed to making the adjustments as we had discussed, depending upon the amount of membranes that you have. Basically, once we have the system started up and we've had all the adjustments made on the pressure for the membranes, we want to go ahead and look at all the fittings on the RO system to ensure that we don't have any leaks. So you'll definitely want to look at the interconnections between the membranes, all these polyflow connectors on top and on bottom. You want to look at the backside where all the gauges are located, and the flow meters. All that you want to inspect and see if you have any leaks. And of course, if you do, you want to go ahead and correct those leaks. You'll want to check the inlet side. You'll want to check the pump outlets, the pump inlets. Also, the carbon filter could also have leaks if you haven't connected the bypass valve correctly. So you want to check all that out and make sure that we do not have any leaks. Now we're going to talk about filter replacement. As I'd mentioned before, you want to take a look at the filter in and filter out. If you've got more than a 10% differential on the filter out side, say you got 30 psi on this side and 20 on this side, it's time to replace this filter. Real simple. Use the filter wrench that's provided and spin it right off. Remember, this is going to have water in it, so be careful as you're removing it so you don't spill water all over yourself. But basically, once it's ready to come off, this will be full of water. You remove the filter, and put in a new filter. At the bottom, it has a little setting in there that goes inside of this hole in the filter. Then, again, just go ahead and reinstall this. And you go ahead and you get it hand tight. Then you put the wrench on and you get another quarter turn and you're all set. So one thing I did fail to mention is that you have an O-ring on this. Use a non-petroleum based lubricant for that O-ring just to make sure that it seals up and as it's spinning so it doesn't bind and you lose the seal. I've already gone through the installation of the lines from the anti-scalant pump to the inlet line, the chemical injection line on the system. Now we're going to discuss the operation and how to fill this. So basically, when you're refilling this 30-gallon tub, it needs to be RO water. So what we have is over here on the permeate outlet line, you'll notice we have a little T with a little valve here that we can install a hose on. And we install a hose about the length to get over to the anti-scalant pail. And we go ahead and use this valve and turn it on. And we can fill up the anti-scalant with RO water. It has this convenient little opening here, which you could put the hose in. And also, this is where you will pour in your anti-scaling chemical. Now, we're going to provide you with a chart on the ratios for this because basically it's not just one set ratio that we put in here. It all depends upon how many membranes the system has. So this system has 2 membranes. So in this particular application, it's going to be 39.9 ounces. The measuring cup to measure 40 ounces total from the trusty pail over here. And you'll pour it in, and that is what you want to mix. But for example, if this was a 3-membrane, then we would be using 56.4 ounces of chemical, and so on and so on. So we'll provide you with a chart, and it's really important that you follow the guidelines, because what happens is the more membranes you have, the more water that you're flowing through. So we need to make sure that we have a higher concentrated of the anti-scaling chemical we're injecting into the system to compensate for the number of membranes that you have. When refilling your anti-scalant tank, it's very important to insert the proper ratio of anti-scalant per the water volume that you have in here. For example, this particular unit needs 39.9 ounces of anti-scalant. And some people say, Victor, why don't you just put in 40? Well, the whole deal is that, you could get too much of a great thing, and this can cause issues. It could cause, if you make this mixture too rich, it can cause the membranes to clog. So it's very important that you follow the guidelines that are giving. If it says, 56.4 ounces, make it 56.4. Don't go over, don't go under. This will ensure that you're getting the proper ratio to make sure that those membranes get an optimum life. Some of the things that we do to help extend membrane life is we spoke earlier. We talked about the pump pressure and then the differentiation in pressure on the concentrate pressure. And once that drops down on the low, we know that we're getting some scaling. So one of the things that we do is when we replace this filter that we just showed you in the video, we'll go ahead and we'll take this canister and we'll put the pool muriatic acid in here halfway, screw it back on without a filter inside, go ahead and turn the system on with all the valves open, concentrate completely open, this valve also completely open. And basically, you're going to give the membranes an acid bath that will help remove any scaling and get them performing back to optimum. In addition to the flush, the muriatic acid flush, the main things to maintain your membrane life is proper preventative maintenance, changing the filters as needed, making sure you have the proper ratio and that you have this unit filled, making sure that your carbon filter is active and removing chlorine from the system. All these things will help your RO perform better and help extend membrane life, and that reduces the overall operating cost of having to replace membranes. As I'd mentioned before, having a proper ratio mix of the anti-scalant with the water is imperative. And some people will ask, I'm doing my monthly service here and I've still got a couple of inches of water in here. Well, what we're going to provide for you is we're going to provide a 5-gallon bucket that you could fill up with water, and then we'll give you the ratio that you need to use for the particular RO. For example, this one, for every gallon of water, you would use 1.33 ounces of anti-scalant. So basically, we would add that and then fill this as needed so that you're putting in the proper ratio into the pump. As we had mentioned before, getting the proper ratio of antiscalant with the RO water mix is imperative to make sure that the injection performs to keep those membranes as best possible. So you're going to do your service and you come out and you still have about 3 inches, 4 inches of solution in here for the injection. And of course, what you're going to need to do is grab a 5-gallon bucket, fill it up with the RO water, and then you, depending upon which system that you have, this system in particular is 1.33 ounces per gallon because it's 2 membranes. If you have a 3-membrane system, then it's going to jump up to 1.88 per gallon. So you're going to look at the chart and you're going to add the antiscalant to that 5-gallon bucket, stir it well, add it to the system, and keep repeating until you fill up the system once again. We're going to talk about membrane replacement. As you can see, I've already loosened this particular one, but basically it's a band clamp. And I don't like using power tools on these because these are stainless steel. So just use your ratchet and crescent wrench and remove it. You'll notice that you have clamps on both sides, but you really only need to remove one side, and then the clamp will drop off. When you have multiple membranes, always remove all the clamps together before you pull up on the covers. You have the bands loose. You want to use a screwdriver to pry. You're going to notice that the caps have little notches 180 degrees away from each other. So you want to use your pry device, a screwdriver, whatnot, and pry them out slowly and evenly because you don't want to kink this hose here. So right now we've pretty much got this removed, and right now we have just a slight bit of vacuum going on. So we removed it, and as you can see, this has that non-petroleum based lubricant on it to seal, the same kind that we would recommend using for the inline filter O-ring. So we'll go ahead and we'll put this down right over here and focus in on top, and you'll see exactly how the membranes look. Okay, so now that we have the end caps removed, we have the membranes inside of here. I'm not going to remove these because they've got the glycol solution in them that will make a mess everywhere. But basically, it looks like this. And when you're removing it, it's okay to grab a needle nose and grab right here. But we always recommend grabbing at the honeycomb area, the little slots there, and getting a pair of needle nose and pulling it out so that you can remove it. When I'm putting in the new ones, you can only handle it by that. You do not want to put any pressure or damage the surface, because this hooks up to an O-ring and seals up. And if this surface is not properly seated, it will leak and you'll get poor water quality. So, putting in the membrane, you could put in a membrane backwards, yes. So basically what you've got here is that each membrane vessel will have a arrow. In this instance, this one is upward flow. So what we do when we have an upward flow, we install the membrane with the O-ring seal downward and put it in. As you notice on the next one, because they're hooked up in series and water's flowing through, the next one is flowing downward. So when you install the membrane on the unit with the arrow pointing in the down direction, you want to make sure that you get this seal and have it in the up position. So once you go ahead and remove those and install the membranes in the proper directions, you're going to go ahead and put the caps back on. Now these have seals, so you want to make sure you use the lubricant to lubricate the seals for the membranes and also the seals for the vessels themselves. And once that's installed, you will go ahead and reinstall these using light pressure. Install the band clamps. and you've completed. And when you tighten these up, I don't know, had just a couple of churns past its seating. Yep. And the one thing that I forgot to mention when we were working with the membranes, obviously we had that one in the wrapper, so it's okay to handle it the way that we were handling it. But when you're removing the old membranes, you don't have to worry so much. Remove everything. After you get everything removed, put on a set of clean rubber gloves. Open up the vessel remove the membrane from the bag enclosure and handle it with your hands, and make sure that you don't get any contaminants on the membrane itself, and install it. And repeat on the other membranes. Make sure that you don't handle it with your hands, your finger oils. Any contaminants you'll get on this will degrade the life of the membrane. So remember, use rubber gloves when handling these once removed from the package while installing.